Hey everybody, back with another Polars tutorial. Hope everyone's doing real well today. So today I'm continuing on a discussion. I started a couple videos back on event history and duration analysis, except this time I'm doing a different type of event history analysis. I'm going to be doing a video on spell analysis today, and so that leads to the question of what exactly is spell analysis, and how is it different from normal event history analysis? So in event history analysis, we're interested primarily in the amount of time that elapses until an event occurs. So for example, how long it lasts for someone to become unemployed or for someone to be admitted into a hospital. In event history analysis, that's a little different. We're more interested in analyzing how long an event lasts after it happens. And so we refer to the amount of time an event lasts as a spell. And to give a few examples, the duration of a spell of unemployment. So after you become unemployed, how long does that spell of unemployment last? Does it last a month? Does it last a really long time, like a year? That duration of time that you're in that status, we refer to that as a spell. Another good example that you oftentimes see in health research is the duration of a spell of a hospital visit. So a hospital visit or being admitted to the hospital would be an event. The duration of time you spend during that hospital visit, in other words, the amount of time that the amount of time that hospital visit lasts, a month, 2 months, whatever it may be, that's the spell. And so to analyze spells today, I'm going to be using some weather data I found on the City of London. It's daily data going from 1979 to all the way to 2020, so it's very interesting. And the kind of spells I'm going to be analyzing today are the duration of days, or the number of consecutive days that last without any sunshine, so just complete cloud cover from morning to noon, so 0 hours of sunshine. And so those are going to be the kinds of spells we're analyzing today. And just kind of eyeballing the data, we can already see some spells, right? We can see a spell right here of consecutive days without sunshine. So this spell lasts for 2 days. Here's a spell that lasts only for 1 day. And here's a spell that lasts for a number of days. So what is this, 10 or 11 days without any sunshine whatsoever. So foggy times in England. And so here's what we're going to do with the weather data. We're going to get the number of spells of days without sunshine. So again, we identify these spells as consecutive days of sunshine with 0.0 hours of sunshine per year. So we're going to do this by year so we can analyze and compare these spells by year and get some pretty interesting statistics. We're going to get the maximum number of consecutive days without sunshine per year. So the number of consecutive days without sunshine in 1979 and 2020, 2019, and so on and so forth. So we can see if these weather patterns have changed over time. And then we'll get the average duration of consecutive days without sunshine. So in other words, in 1979 is the average, if the average number of consecutive days of without sunshine was, say, 5, and in 1980 it was 2, we would say that on average these spells of these number of consecutive days, these spells of days without sunshine, they lasted longer in 1979 than they did in 1980. And so now we'll get into the coding. And so first we kind of have to think critically of how do we identify these spells and how do we actually programmatically kind of measure how long each of these independent spells last. It's kind of tricky when you start to think about it. So you just kind of have to break it down step by step. There's a lot of different ways to do this. Here's how I do it. I always start the same way every time I do event history analysis. I always identify the start time. And I tag these records with an indicator variable. And so to tag the start time, you kind of have to come up with a good definition and just kind of get that definite in your mind of what a start time is. And at least with our use case here, with these data with which we're working, a start time can mean one of two things. It can be the record where sunshine, the first record where sunshine is equal to 0.0, and the prior record is not equal to 0.0. So for this case right here, this January 14th date of 1979, this would be the start of a spell, and it would be the start of a spell because it is a day without sunshine, and the prior record was a day without sunshine. And so that brings up a problematic aspect. What if the first day in the year doesn't have sunshine, right? There's no prior record to compare it with. So the second way in which a start time can be identified is if it's the first record in a given year and sunshine is equal to 0.0. And so in order to identify the first record in a given year, the first thing we're going to do is create a record counter that goes from 1 to 365, or I guess 364, 366, whatever it is if it's a leap year, for each year. And so to do that, we just create a record number, we initialize it by 1, and then we just do a cum sum over that, and then we do that over year. So that way it kind of goes from 1 to 360 some odd every year. So we'll just go ahead and print that out and just get a look at it and just kind of see how our data unfolds step by step. Whoa. Hello, black screen, huh? How I missed thee. Okay. Okay, so here's our record number. And so this is very key because it allows us to identify the first record in a year and to also test if that first record in the year is equal to 0.0. And so we'll just scroll to 1980 to make sure it rolls over back to 1. Yep, there we go. Great, so that should give us everything we need to identify and tag our start and stop times. And so here's what that looks like programmatically. And so again, you just have to think through it piece by piece. So we have two conditions here that we need to tag. We need to identify records where sunshine is equal to 0.0 and the prior record is not equal to 0.0. So in other words, this record right here, this record right here, and this record right here, and so on and so forth. And so you can just kind of program that out exactly as we described it here. So we have PL1, so this is a logical test that we're doing. And so we're creating a new column. And so we have sunshine equals to 0.0. And we're going to use shift. And what shift is going to do is it's going to create a lagged variable. So a lagged variable, or a lag, is just shifting this variable down right here. So we can compare this variable on this row. So it's just it's comparing the prior record. So if the current record is equal to 0.0 and sunshine in the prior record is not equal to 0.0, then we're just going to tag that with a value of 1. And so second, we're going to look for the first record in a given year and where sunshine is equal to 0.0. And this is comparatively more easy. We just already have our record counter, so we look at cases where the rec number or record number, so this guy is just equal to 1, so it's the first day of a year, and sunshine is equal to 0.0. And then we'll return a 1 there, and we'll call this variable spell ID, and we're going to do it over year because we want all these computations we're doing to be specific for each year because we're trying to compare years when we finally get around to computing statistics for these. So we'll just take a look at how this tagging went. And if this seems a little obscure right now, it'll all come together once we take a closer look at our data here. Okay, so again, all we're trying to do right now is tag the start times for each of our spells. And so it looks like it's working here, right? So this first record right here, this is the start of a spell. This first spell of a day without sunshine. And we see it lasts for 2 days. We'll take care of that in a moment. But we're just looking for the start times right now. So this is a spell of 1 day, and it's good we tag that guy. It's the start of a spell, but it's a spell that lasts for 1 day. It's relatively short. And here's a spell that lasts for a long time, but we tag the start time, so that is good. And so now the next step, so now it's good that we tag the start times, but these really aren't that useful. Next we want to get an identifier on each of these unique spells. So we want this whole spell right here to have its own unique identifier, and that'll give us a very easy grouping variable that we can use to compute statistics with. So I'm just going to go ahead and drop record number here because we don't really need it anymore after this, and it's just kind of in the way in the output. But it's pretty simple what it did and the purpose it served. And so that's the first part. The first step is just identifying the start time of each spell. The second step is we want to create a spell ID for each unique spell within a given year. And so we want to use CumSum on the spell ID created in the prior step, and we want to group this operation by year. So in other words, we want this spell to have the spell ID of 1. We want this spell to have the spell ID of 2 because it's the second spell that we're analyzing. We want this spell to have a group ID or spell ID of 3. So giving each of these spells a unique ID helps us tabulate statistics on each spell independently. And that's very easy to do. So we're doing with columns, and we're creating a new column called spell ID. And we do that by just taking the spell ID created in the above column, and we just do a CumSum on it. And so it's going to cumulatively sum. So it's going to tag this one as 1, this one 2, and this one is 3, and so on. So it's just going to keep adding 1 as we move forward. And again, we're going to do this over year because we want all this to reset and roll over when we go into 1980 and 1981, 82, 83, and so forth. So let's we'll just print this out step by step, just so the kind of coding we're doing just doesn't appear overwhelming. And everything we're doing here isn't that particularly difficult. It's just a lot of steps and a lot of things to think through, to make sense of. Okay, so this is good. So now we see that each of our spells that we're analyzing here have their own unique identifier. So here's spell 1, spell 2, spell 3, spell 4. And I think I forgot to mention that all of this is daily data that we're using. Actually, I think I may have mentioned that, but all of this is daily data that we're using, so we don't necessarily need to compute the duration by taking the difference between each date. We just know each record corresponds to a day. So the difference between one record and the other is always the same for each of these, which is very nice. It makes it easy to work with. Okay, so now that we've given each of these their own unique identifier, we want to expand this identifier to each unique record within the spell. So how do we do that? So we notice that each of these cases within the spell have a value of null except for the first value. So if we can test if these are 0.0 within the spell, we can tell pollers to forward fill the spell ID as long as these records are 0.0. And that should give each spell its own ID. And so this is part 3. We want to tag the entire spell with the unique spell ID. And we accomplish this. How do we accomplish this? We forward fill the spell ID as long as sunshine is equal to 0.0. And this will provide us with an easy-to-use grouping variable. And this is actually pretty easy, just programmatically, once you kind of think through it. So again, we're constantly recoding our spell ID. We do pl.when, and when pl call sunshine is equal to 0.0, we forward fill, and that'll forward fill the spell ID. And so what forward fill is going to do is it's going to fill in all the nulls. And this is going to work so long as we tagged our start time correctly. If we tagged our start time incorrectly, this isn't going to work. So definitely make sure you're diligent about tagging your start times correctly. And the way in which you go about tagging your start times may not be as identical as it would be in this video because your data is going to be different. And that's a challenging part about longitudinal data. There's so many different kinds of longitudinal data out there, and each one presents its own unique challenge. The reason I'm working with this data set is because it is kind of interesting to use, and it is pretty cleaned up, right? Like each record represents something very kind of easy to understand, just a day of time. So we'll go ahead and run this, and this will make everything kind of come together here. Okay, so here we go. So now we have every record in this discrete spell tagged with a value of 3. And it's a value of 3 because this is the third spell that occurs. Here's the first spell. Here's the second spell. This spell only lasted for 1 day, but it has a spell ID of 2 because it's the second spell that occurred. This spell has a value of 3. It lasted for quite a number of days, but it has a value of 3 on this spell ID because it's the third spell that occurred. This is the fourth spell. This is the fifth spell. So most of these spells are relatively short. some of them go on for a number of days. And let's see if we can just kind of eyeball and see how many unique spells were in this 1979 data. So 32, and within 1980, oh, it doesn't get down, but we can see the 6th spell that elapsed just with this sample printout of 400 records. Okay, so now we can use the spell ID to create some summary statistics by year. After this point, it's all very easy. And so we're going to start by getting the duration of each spell by getting a count of the records within each spell ID and year. And so that's very simple. We're creating a new column. We call it spell ID. We're doing a with columns. I don't know why I spaced it like that. That's kind of weird. But we can easily get a record count of spell ID. So the way we're going to get the spell duration is we're just going to take a record count of the days within each spell ID. And we know it's just time in days because, again, each record represents a day. And so if we take the length or the number of elements within this grouping right here, this grouping right here, this grouping right here, and so on, that should give us a measure of the duration of each spell. And so the way we do that is we're going to point to spell ID, so this guy. We're going to take the length, and we're going to compute that length over year because we want all these computations done by year, and then by spell ID as well. Okay, then I had some extra code down here. So that's why I spaced it like that. We have 2 with columns. And so what I do right here is I just take spell duration and I set it to missing when spell ID is equal to null because we don't want to compute duration of these null spells because these aren't spells in our definition. But that's a comparatively minor point. Fun stuff. All right. So using that length function, you can see that we have a spell duration column now, and it measures the amount of days each spell lasts. So this spell that has a spell ID of 1 lasted 2 days. This spell that has a spell ID of 2 lasted 1 day. This spell that has a spell ID of 3 lasted 10 days. So all very easy. And so now what we can do, now that we have this basic data, is we can just unduplicate this. So in other words, we can just take each unique spell and just subset this out. And so that's kind of tricky to do if you're new to polars. But the first thing we can do is we can just use the filter method, which filters records. And we can just say PL call. We can point to the spell ID column. And we can say that we only want to keep records where spell ID is not null. So in other words, only if it's a spell that we're interested in analyzing. And then we want to pass that to another data frame method that I don't think I've ever talked about in this tutorial series before, but it's nonetheless very useful. It's for deduplicating records. It's called .unique. And .unique is just designed to do what it sounds like. It's to keep unique records and to get rid of duplicate records. So here what we're going to do is we're going to subset the data by year and spell ID. And we're going to keep the first instance of this duplication. So the first instance of 3 in 1979, we're going to keep that. The first instance of 4 in 1979, we'll keep that record. The first instance of 7 in 1979, we'll keep that record, and delete the duplicate records. And then maintain order equals true, just make sure that it maintains the original order that the data set originally occurred in. And so maybe I'll just leave this here to just give you all a moment to just study this code and just kind of think about what it does, because I know I'm kind of going through this quickly and it is kind of a lot to think through. But if you just kind of look at it and just sort of study it, you'll see it's just not that bad. But I will go ahead and run this. Oh, whoops. I'm actually creating a new data set here. It's called spells now, not weather. My mistake. Okay. So there we go. Now we have a unique record for each spell ID, spell 1, spell 2, spell 3, spell 4, and the spell duration. So again, we saw that if we recall, this spell lasted for, this was the first spell, it lasted for 2 days. This was the second spell, it lasted for 1 day. The third spell, it had a duration of 10 days without any sunshine whatsoever. And so now that we have that, we can very easily calculate some summary statistics. So what we're going to do is we're going to print, then we're going to take our spell data set, we're going to group by year. So 1979, 1980, 1981, every single year. And within each of these years, we're going to calculate the number of spells in a year. And we can do that very easily by just looking at the spell ID and getting the max. So the maximum spell ID for 1987 is going to be 44, because we know that there were 44 unique spells in 1987. And there were also 44 unique spells in, oh, I'm sorry, in 1986 there were 47. How many were there in 1985? So 40. So by using the spell ID column, it's really easy to get the actual number of spells that occurred in a given year. So that's why that spell ID is so useful. We're going to look at the maximum duration of a spell within a given year, and we can easily do that. We can create this max spell duration column by looking at spell duration and getting the max again. So we can use, oh gosh, I printed out too many records. Sorry, guys. We can use a spell duration column and get the max within a given year. And the maximum should tell us the longest number of consecutive days that occurred without any sunshine. And then we can get the average spell duration by just pointing to the same column and getting the mean. So very interesting stuff. So we'll go ahead and run this and print it out. Let's make sure I got rid of all my sys.exits. Looks good. And hey, there we go. So here's our final table, and we see that it's pretty interesting. We see that from 1979 until 2020, we have some really useful statistics on the number of spells without any consecutive days of no sunshine. The maximum number of consecutive days without any sunshine that occurred. So we see that the maximum number of days in 1979 was 10. In 2020, it was 4. In 1997, it was 7 consecutive days. And we see that the maximum changes quite a bit, but we see that the average is more or less the same. These spells are all short. They're usually between 1 and 2 days. And just for fun, I think I forgot to do this. Let's calculate the median. Errors. Yeah, so we see that the fact that most of these are 1 tells us by and large the vast majority of these spells are probably just have a duration of 1 day. Okay, guys, so thanks so much for watching. That's a brief introduction to a variety of event history analysis where we analyze spells. It's a little bit different than normal event history analysis, but as you can see, if we just kind of utilize some very simple programming tricks, we can make it pretty easy. So thanks again for watching, and have a good rest of your evening.